Bonsuelo athletes. Okay, word problems. I'm going to try and show you where you have to be careful here. Okay? There's something that's going to be new that you have to be careful of. And so we'll just go straight to it. Okay, first problem. Snard can train a flea to jump through a hoop in 20 minutes, and Elvis can train a flea to jump through a hoop in 30 minutes. How long will it take them to train 8 fleas if they work together? Okay, thing you have to be careful here is this. There's their time alone. So Snard does something alone in 20 minutes, and Elvis does something alone in 30 minutes. And then we're talking about how long, okay, that's time together. So there's time alone and time together. And you have to be very, very careful because the time alone is an indirect way of giving you their rate, okay? So this thing here of Snard doing something for 20 minutes alone and Elvis doing something alone in 30 minutes is not the time they spent doing something. It's kind of like saying this. If I can paint a room in 3 hours, did I actually necessarily ever paint the room? No. That's an indirect way of giving you my rate. Okay? If I say I paint for 3 hours, yes. But if I just say I can paint in a room in 3 hours, that's an indirect way of giving you a rate. Now, let's just go to it then. So what are we looking for? And it's very important, the definition. There's how long. So we're talking about time, but it's not just time because there's both time alone and time together. This is the time together. Okay? So again, the equation we want to write is them together. So what do? The total work is 8 fleas. The total number of fleas, if you want. So what's that? A total is going to be the sum of two things. So we have Snard's work, or Snard's fleas, if you want to call it that, plus Elvis's work equals 8 fleas. Okay, well, how do you find work? It's rate times time. Plus rate times time. Okay. Well, do we know any of these things? Well, their time. Is the time of Snard 20 minutes? No. Is the time of Elvis 30 minutes? No. That's an indirect way of giving you the rate. Remember, what we're looking for is time. Time together. That's X. Okay. And they each work that time. And again, I strongly suggest you not look at Alex. They do it a way that doesn't really always work. Okay. Don't look at the Alex explanations. Okay, so what's this 20 minutes? That's an indirect way of giving you their rate. So it's kind of like saying this. A rate is usually something divided by time, like miles per hour. Okay, that's a rate. Miles divided by hours. Well, what's the rate here? It's fleas per minute. Well, if Snard can train a flea in 20 minutes, how many fleas does he train per minute? And it's the reciprocal of that. It's 1/20th. Now, again, these videos are not intended to take the place of class, okay? I'll spend a good deal of time in class trying to explain this, but I think it does take more explanation than I can give you. It takes a explanation in person. Okay, so but this is the time alone is his rate of 1 over 20. And Elvis's time alone is 30 minutes. His rate is 1 over 30. Okay? Now, at this point, then, you have an equation. And what do you do to solve this equation? You multiply by the lowest common denominator. And what's the lowest common denominator for 20 and 30 is 60. So we're going to multiply both sides of the equation by 60. Okay, well, 60 times 1/20th x gives you 3x. Because the 60 and the 20 cancel to give you 3. 60 times 1/30th x gives you 2x, because the 30 and the 60 cancel. And then the 8 times 60 is 480. Okay? Now, then what happens? At this point, we just solve it. 5x equals 480. Divide by the 5, and you get 96. So, it takes 96 minutes to train 8 fleas while they're working together. Okay? All right. Bob can mow 6 lawns in 90 minutes, and Wilma can mow 6 lawns in 130 minutes. How long will it take them to mow 6 lawns if they work together? Okay. So what do we have? Again, time together. Okay, what do? Well, they mow 6 lawns, because it says how long will it take them to mow 6 lawns. So the total work, the total lawns, if you want, equals 6. Okay, well, what's that? That's the Bob's work plus Wilma's work equals 6. Okay, that's each of them then is just rate times time. All right, well, what's their time? That's x, because that's the time together. Remember, this equation's for them working together. Well, what's their rates then? Okay, well, Bob does 6 lawns in 90 minutes. So what does he do? 6, remember, it's like lawns per minute. So it's 6 over 90. Okay, and Wilma can mow 6 lawns in 135 minutes. So it's 6 over 135. Okay? And now at this point, we're going to multiply by the lowest common denominator, and I'm not going to spend a lot of time going through this, but notice that the 6/90ths will reduce, because I can take a 3 out of each one, to 2/45. I'm not sure if this is going to make it easy or not. X plus 6 over 135. X equals 6. Now, what's the lowest common denominator for 45 and 135? No, it's not 45 times 135. And again, I'm not going to go through the common denominator. That's something we've done before. But if you factor the 135, you're going to find out that it's 45 times 3. So the lowest common denominator is actually 135. So I'm going to multiply both sides by 135. So the 45 cancels with the 135 to give us 3, and 3 times 2x is 5x. The 135 in the second fraction just cancels, so we get 6x. And then we're going to take 6 times 135, and that's going to be 810. So we just multiplied 135 by each side. Okay, so then that's 11x equals 810. And then we're going to divide by 11. And it's going to give me, I don't know, some number, it doesn't divide in evenly, but it's going to be 810 over 11. And you can write the answer several different ways, but like this would be 73 and 7/11ths, which I don't really care if you give me the 810 or whatever, so, or the 73 and 7/11ths. So it takes them (73 and 7/11ths). What is this? Minutes. To mow 6 lawns together. Okay. Now let's see this one. Together, Fred and Barney take 4 minutes to waterproof a snail. If Fred would take 14 minutes to waterproof a snail while working alone, then how long would Barney take alone? Okay, so X is not their time together. I just want Barney's time, but Barney's time how? Barney's time alone. That's very important. Okay? So what do we know? They waterproof what? 1 snail? Okay, so total snails or total work, whatever you want to call it, equals 1 snail. So that's going to be Fred's work or Fred's snails, whatever you want to call it, plus Barney's work equals 1. Okay, and how do you find each of their works? We have rate times time. Okay. Now remember, this time is their time together. X is Barney's time alone, but remember, this time is them working together. So what's the time for them to work together? 4 minutes. Okay. Well, it says here that Fred would take 14 minutes alone. So Fred's rate is 1/14. What's Barney's rate? Well, notice his time alone is X. So his rate would be 1 over X. If Fred's time alone is 14, giving you an indirect way of giving his rate is 1/14, then Barney's time alone, which is X, is an indirect way of giving his rate, which is 1 over X. Okay? Now, let's multiply and get rid of fractions. First of all, we can simplify this fraction, 4/14, and call it 2/7 plus, and this fraction would be 4 over X equals 1. And what's the common denominator? X. So we're going to multiply both sides by x. So this would be, actually, you know what? Let's multiply. I should have multiplied and got rid of all fractions. Sorry. What's the common denominator for all of that? 7x. So if I multiply the first fraction by 7x, the 7's cancel, and you're left with 2x. If I multiply the second fraction by 7x, the x's cancel, and we get 4 times 7, which is 28. And then on the other side, you just end up with 7x. And then I subtract the 2x on both sides, get 5x, and then divide by 5, which is 28/5, which is what, 5 3/5, which is, again, I'm not that concerned whether you call it 28/5 or 5 3/5. Probably makes more sense to call it 5 3/5. But so Barney takes 5 3/5 minutes to waterproof a snail. Okay. All right, let's take a look at this last one. This one's a little different than all the other ones. This is not about doing some sort of work. Okay, Kyle swam 8 miles against the current in the same amount of time it took him to swim 16 miles with the current. How fast would Kyle swim if there's no current? So we're looking for speed, Kyle's speed, and the definition is all important without current. Okay. Well, what's the one thing they tell us? Well, this is about against. Remember, you kind of need to know about what the problem is about. This is going against the current and going with the current. And what it says is the times are equal. Okay? So the time with the current equals time against the current. Okay, well, how do you find time? Well, remember, distance equals rate times time. So time would be distance divided by rate. One going with the current, the other one going against. Okay. So what happened here? He swims 8 miles against the current. Okay? He swam 16 miles with the current. Okay, now, how fast does he swim? Well, if there's no current, he goes X miles per hour. But if he's going with the current, he's going faster than that. He's going to go 2 miles per hour faster because he's got the current pushing him along. And if he goes against the current, he's going to go slower because he's got the current hitting him in the face. So he's going to go X minus 2. Okay, and then at this point, we just multiply by the common denominator, which is X minus 2 times X plus 2. Now, on the left, the X plus 2's cancel, so we get 16 times X minus 2. On the right, the X minus 2's cancel, so we get 8 times X plus 2. And now instead of distributing, why don't we make things a little simpler and we'll, divide an 8 out from each side. Sorry, 8's there, I should have just crossed it off. And I'll divide an 8 out of this, and it's a 2. So now we take 2 and distribute it to the X minus 2, 2X minus 4. And there's nothing to distribute here, so we get x plus 2. Now I put the x's on the right, so 2x minus x is x. I add the 4 to the other side, and you get 6. So Kyle swims 6 miles per hour when there is no current. Okay, and that's about it, I guess. Okay, so the two new things here, the main new thing is this idea of time alone versus time together. Time working together is the time they actually spend doing the thing. Time alone is just an indirect way of giving you the rate. Okay, that was the first 3 problems. On the last problem, the main thing that's new here is the fact that when you have a current or a wind or something like that, if you're going with the current or the wind or something like that, you take the speed without the current and add the current or the wind. If you have going against the current or the wind, you take the speed without the current and you subtract the current or the wind or whatever it is. If you have any questions, please ask. Bye-bye.